In this video, we're looking at the integral from -1 to 1 of x squared times the quantity x cubed plus pi all squared. And one way to handle this integral would be to expand that squared binomial, distribute the x squared, and integrate each of the individual terms. But it's much simpler if you recognize that the derivative of that interior function is basically sitting there in the integrand. The derivative of that interior is 3x squared. And what we have next to the squared binomial is x squared. So it only misses by a constant. And this means a u-substitution will work. So I can say let u equal the interior function x cubed plus pi. And this means du is going to be 3x squared dx. And then one way to handle the transformation of this integral is that I can just put the 3 inside the integrand. So I have my 3x squared now, and 3x squared dx is just du. And then I compensate out in front with a 1/3. Before I rewrite the integral, I want to transform the limits of integration as well. So when x is equal to -1, that was my lower limit, u is going to be -1 plus pi, because I take -1 cubed, which is -1, and add pi to it to get u. And I would rather write that as pi minus 1. When x is +1, I plug that into my definition of u again, and I get a 1 plus pi, or pi plus 1. And now I'm ready to transform my integral. So I have a 1/3 out in front, and then an integral as x goes from -1 to 1, which means u is going from pi minus 1 to pi plus 1. And then my squared binomial is just u squared, because I let u equal x cubed plus pi. And then my 3x squared put together with my dx, that just gives me du. So I just have a u squared du. And then the antiderivative of u squared is just 1/3 u cubed. And we're going to evaluate this from pi minus 1 to pi plus 1. Now the 1/3 times 1/3 can be combined into a 1/9. And when I sub in my upper limit, I'm going to get a pi plus 1 quantity cubed. And in my lower limit, a pi minus 1 quantity cubed. And I have to remember how to cube a binomial here. We could just brute force it and just write down pi plus 1 times pi plus 1 times pi plus 1, and then distribute and expand into all the terms that are possible and combine like terms. But it's nice to remember how to cube a binomial in general. And I'll just put those formulas over here on the left. So applying those binomial formulas, the expansion of pi plus 1 cubed is going to be a pi cubed plus 3pi squared plus 3pi plus 1. And then I need to subtract from that a pi cubed minus 3pi squared plus 3pi and minus 1. So a couple terms cancel out here. There's a pi cubed minus pi cubed. And here's a 3pi minus 3pi when I distribute that -1. The other two terms end up adding to each other. So for example, I have 3pi squared minus -3pi squared. Well, that's 6pi squared. So I have 1/9 times 6pi squared. And then I have a 1 minus -1. And that gives me a plus 2. And I suppose 6pi squared plus 2 all divided by 9 is a nice way to write the answer. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.